Okay, so today we're going to talk about the mole and a little bit of Avogadro's number. So, we've seen if you work with atoms or, things very, very small, sometimes it's not always convenient using units that we would use in our everyday life. So, what we have is something called 1 mole. Now, a mole is just like any other unit. It's just like feet, it's just like inches, it's just like pounds, grams, whatever you want to think of. It's just a way of quantizing some amount of something. So, as we see here, 1 mole is 6.02 times 10 to the 23rd atoms. That's an approximation. It's a little bit more than that, but that's essentially what we're looking at here. Now, if you had 6.02 times 10 to the 23rd pencils, you would have a mole of pencils. Obviously, there's not that many pencils in the world, so we don't exactly see that. But once you get on the scale of things like atoms or molecules, you will see that many atoms. So having its own unit makes sense. Okay, so that's essentially what we're working with here. Now, hopefully that kind of makes sense because we'll be building off of that. Let's say you had 6.02 times 10 to the 23rd, or a mole of carbon, of water. We'll just use some symbols. Oxygen, sodium, whatever you want to have. Let's remember that a mole is just an amount of something. It's not necessarily how much something weighs. So a mole of carbon might be more or less than a mole of oxygen, or a mole of sodium, or a mole of lead, or whatever you'll have. So just keep that in mind, that just because you have a mole of carbon and a mole of oxygen, that doesn't mean they weigh the same. And that gets into molar mass, which we'll talk about in a little bit. In fact, it's probably worth talking about just right now. Let's look at the example of water. Water is just H2O. If you have a mole, right, let's say you have your H2O molecules, and you want to know how many total atoms there are. Well, if you have a mole of water, we know that's 6.022 times 10 to the 23rd. We have that many molecules, but we have 2 hydrogen and 1 oxygen, so you have 3 atoms that make up this molecule. And you have 6.022 times 10 to the 23rd of those molecules. So if we were to multiply that out, our 3 times 6.0222, I don't have it in my calculator here, and I don't feel like putting it in, but it would be give or take like 18. I think it's like 18.0 something. So H2O has 3 atoms that make up this molecule. And there's this many molecules, so you have to multiply each atom by that number to get the total amount of atoms that you would have. Okay? Hopefully that kind of makes sense. So now that we know what a mole is and kind of what it represents, one of the big picture ideas here is using moles as a way to convert. Okay? So let's say you have 8.98 times 10 to the 25th atoms of titanium, which is just Ti. Okay? I want to know how many moles of titanium I have. So the way we do that is we take what we're given, atoms Ti of titanium, and we need to cancel this out. Well, we know that 1 mole of titanium, which is what we want to look for, is 6.022 times 10 to the 23rd atoms. Okay, we can see here that your atoms drop, and if you put this in your calculator, you should get 149 moles of titanium. Okay, here's a practice one for you to try. Let's say we have a sample of potassium that contains 5.87 times 10 to the 23rd atoms. How many moles of potassium do we have? Well, follow the same idea here. Start with what you're given. Potassium atoms. Okay? I should probably use K because that is the atomic symbol. So helpful to do that. Can you tell I don't work with chemistry too much? Okay, so converting this, we have 1 mole of potassium is equal to 6.022 times 10 to the 23rd potassium atoms. And then these drop, and after you plug this in, you get about 0.975 moles of potassium. So hopefully that makes sense. That's the first bit of working with a mole, and hopefully we can do more.